Hi there. So in this quizzes, you're going to have a couple different slides with little short videos like this one that walk you through an example. And then the other slides in the quizzes will be practice questions. And the topic of this lesson is section 4.8, where we're solving rational equations. So the method we're going to use is called fraction busting. And it's a method that we use when our equations have fractions in them, which is what a rational expression is. If you remember, it has that word ratio. So basically, it's equations with fractions. Okay. Now, the reason we didn't use this process earlier in this unit is because we weren't working with equations. We were working with expressions. And the thing that's unique to solving equations is the fact that there's an equal sign. So we can use this method of fraction busting. What that means is we're going to be getting rid of our fractions by taking advantage of what's called the multiplication property of equality. So that says we can multiply anything we want to an equation as long as we multiply the same thing to both sides. So the same thing that we're going to multiply to both sides in this context is going to be the lowest common denominator, because that will allow me to get rid of all my fractions and also satisfy the multiplication property of equality. So I want to just start off with a simpler one just to kind of get the hang of what I mean by fraction busting. So I'm going to start it off by finding the lowest common denominator between all of my denominators. You'll see I have a 5 in one denominator, an n in another one, and then 3 times n in the third one. So if you remember, our process for finding a least common denominator was to first consider common factors, which in this situation would be n. I have an n in common between two of my denominators. And then we also want to consider whatever factors are remaining, which would be 5 and 3. And then we just multiply the common factor or factors to the remaining ones. So in this case, it would be a 5, a 3, and an n. So my LCD is just 15n. There we go. If I multiply that to each part of the equal sign, because it contains the factors, this LCD contains the factors that can be found in my denominators, it will in effect get rid of all of those denominators. So when I multiply by the LCD, I'm going to multiply by the LCD over 1. That means it's only getting multiplied to the numerator. And again, we're allowed to do this because of the multiplication property of equality, because I am changing the value of this fraction here, because I'm multiplying only the numerator. But that's okay as long as I change the value of the other fractions by the same amount, then the equality between the two sides is still true. Okay, now I just need to be careful to distribute my LCD to all terms on each side of the equation. So let me write out what I would have. I would have 15n over 1 times 2 over 5. I would also be multiplying 15n over 1 to my 2n plus 3 over n. And remember, all things in the numerator are technically supposed to be inside a grouping symbol. And then the fraction on the right, the 4 over 3n, is also going to get multiplied by the 15n over 1. So notice, for example, here with the 5 in the denominator and the 15, there's a common factor of 5. So I can divide that out. All of these things are connected with multiplication. So I can divide the 15 and 5, and I'd be left with a 3, an n, and a 2. In the second fraction, I have an n in common. I can divide that out, and I would be left with the 15 and the 2n plus 3. And then in my final fraction, I could divide out an n divided by n, and then 15 divided by 3 to get 5. And I'd be left with a 5 and a 4. And then if you remember from our 4.3 lesson, you go ahead and multiply the leftover stuff straight across. So notice my leftover stuff is only in the numerator. So here I have a 3, an n, and a 2, so I have a 6n. In the denominator now, I would just have a 1 because this 5 divided into the 15. And then over here, I would just have my 15 times my 2n plus 3 in the numerator, and then all of that would be over 1. And then on this one, I would have 4 times 5, which is 20, and then all of that would be over 1. And when you're dividing by 1, it's not really changing the value, so you don't really need to write that. And so what you'll notice is that the act of multiplying both sides by the LCD over 1, when I distributed that to everything, canceled out every single denominator and accomplished what we call fraction busting. Got rid of all of the fractions in one swoop, and so now I have what's called a linear equation. I don't have a rational equation anymore because I don't have any variables in my denominator anymore. This equation is just simply linear. This goes back to the Algebra 1 days, the simple days, right, when things were simple. All I have to do here is just isolate the variable. So I'm going to distribute my 15 so I can figure out what my terms are. And then I notice I have like terms of 6n and 30n, so I will go ahead and combine those. And then here, I just want to move the other values away from n. So I'm going to start by subtracting the 45. And then the last thing I would do would be divide by 36. So my solution for n ends up equaling negative 25 divided by 36. And one quick comment, when you're solving these, you want to sort of go back to the beginning of your work and look at the original equation. You want to take note of whatever variables were in the denominator, because remember, I do need to continue restricting values. So in this particular problem, I'm not allowed to let n be 0. So you just want to keep that in mind. And that's because there was a single factor of n in a couple of the denominators. And so if that n were equal to 0, then I would end up dividing by 0, and this equation would have no solution. But I notice that when I solve, I get an n that's not 0, so this is perfectly fine. This is a value for n that would solve this equation here, which is linear, but it would also be the same solution to this original equation at the beginning. So now on the next few slides in your quizzes, you're going to practice some examples similar to this one. Have fun!